Alright, today we're going to look at writing equations of lines from a graph. So grab your record sheet for your notes 3.1.2 and follow along with me. Okay, you have two options when you're looking at the graph of a line, and it's all based on whether you can spy your y-intercept or not. So if your graph includes a y-intercept that can be easily determined, then you want to choose slope-intercept form, y equals mx plus b. In slope-intercept form, we know m is our slope, and we know that b is our y-intercept. And so those are the two pieces that we need, a slope and the y-intercept. And we know that from the phrase slope-intercept form. Tells you exactly what you need. So let's go and look at our graph. We see a line passing through the points A, B. And although those 2 points aren't necessarily critical right now, we need to focus more on where is our line AB crossing the y-axis. And so if we look closely, it looks like we're crossing right here at -1. Now let's make sure. Let's go back to the points that were given to us, and how are we going to travel from point to point? So let's say I start at point B and I rise to run 1. From there I would rise to run 1, rise to run 1. So we want to make sure that we have that constant rate of change from point to point to make sure that we actually are hitting at a nice, neat corner of our grid for our y-intercept. Okay, so we can be certain that our y-intercept is the point 0, -1. Now that means that I already know pieces of my equation to model this line. So if I'm doing y equals mx plus b, I know y stays as y, x stays as x, and in front of my x, my coefficient, is going to be the number that represents my slope. And then I also know that after my x term, my constant, either added or subtracted at the end, will be my y-intercept. So we just found our y-intercept to be -1. So we can go ahead and drop in our b to our equation. B is -1. Okay, so all we have left is to find our slope. And if we are looking at our counting, right, go back to your graph, we said that our change in y, our rise, was up 2. We're increasing. And our change in x, our run, was a -1 because we're going to the left, so that's negative. All right, we know our slope is going to be a ratio change in y over change of x. From your 8th grade, you remember it as rise over run. Okay, so what is our ratio? Our rise is a +2, and our run is a -1. So simplify. Positive divided by a negative is negative, and 2 divided by 1 is 2. So we know our slope, our m, for the line that we're writing the equation is -2. So y equals -2x minus 1. There we are in slope-intercept form. Okay, so let's say we want to take the equation of this line and rewrite it. Let's take our y equals -2x minus 1. We already found the equation of our line. Y equals -2x minus 1. If we want to convert from slope-intercept form to standard form, then we're going to have to do some rearranging. Standard form isn't something that we can generate from looking at the graph. Standard form is going to come from rewriting. So if we know slope-intercept form, we can make it look like standard form, because in standard form we have ax plus by equals c. Remember, in your equations, x always stays as x and y always stays as y. And so we will have numbers in the place of the a, the b, and the c. Now, we already have numbers right now. In front of our y, we have an understood 1. In front of our x, we have -2 as our coefficient, and our constant c that stands alone is our -1. But we know that if we are going to be switching sides, then we have to go through an undoing process. I can't just take these numbers and put them where I want them to be. It's not the same equation. We have to keep it balanced. So if we want to head to standard form, then that means that we need to be looking at x and y, both of those terms, on the same side of the equation. Right now, my y is on the left side and my x is on the right side of our equal sign. Right? We got to make sure that we keep things balanced. Anything we do to one side, we must do to the other. And so if I need x and y together on the same side, you've got to choose which side you want that to be. So let's say that we want it to be on the left side. And then which piece is out of place? Which one of our terms, x, y, or the constant, is on the wrong side? If we want our variables, x and y, to be on the left, then my x term is on the wrong side, and we need to move it. In order to move it, we have to undo. We got to use our order of operations in reverse. Right now it's a -2x. To undo that, we will add 2x. Anything you do to one side, you must do to the other. So add 2x to the left. Now, when we go to draw our line and update what we have on our scale now, we've got to look at combining like terms. 1y and 2x aren't like terms. X and y aren't the same thing, so we cannot combine them. That means that we just leave them as one long string. And we've had that practice with our literal equations back in Unit 1. Okay, so 2x plus y equals, this is 0, so that's out, and we still have our -1. Now we are in standard form. 2x plus 1y is equal to a -1. Of course, you don't have to write a 1 when it's a coefficient. You can just say 2x plus y equals -1. That's fine. Now, that's standard form. What you want to know for standard form is that you are looking for two characteristics. X and y must be on the same side. So look at that equals. We've got to have x and y on the same side of the equal. Okay, and then the other thing that you need to keep in mind is that you can't have any fractions. None of your numbers can be fractions, and yep, that means also no decimals, right? Integers only. Now, in this case, our coefficients, 2 and 1, were already integers, and our constant wasn't a fraction either. It was just an integer. So we were fine on this one, but if you had fractions, you would need to remove them. Okay, let's look at a new graph. Let's look at this graph of line AB, and we're kind of in the habit of figuring out where is that y-intercept. But when I go to look for my y-intercept, I'm not quite sure what that is. I mean, it looks like it might be negative, let's see, 1, 2 and a half. It might be -2 2/3. I'm not really sure. I can't tell. When I go to count from one point to the next point, I'm going to rise 1, run 1, 2, 3, 4, 5. So that's not letting me figure out exactly where I am either. I mean, I could probably reason through and use some logic, but that sounds like a lot of work to me, and I have a better option. I can just use point slope form. Point slope form requires that you have a point, so you can choose any point on your line, and we call that x1, y1. So any xy ordered pair. We know 2 points clearly on our line. Starting from the origin, this is the point 2, -3. And then I also know point A, which is, count from your origin, 1, 2, 3 to the left, so -3, and down 2, so -3, -2. I can use either one of those, whichever one I prefer. And that will be my x1, y1. So if you need a point, just choose a nice, neat point that's crossing on the corner of a grid. And when I scan my line, you know, I really see B and A, and those are the only two that are on the corner of a grid box. So I'm going to use one of those. I prefer 2, -3. It doesn't matter. You'll end up with the same answer in the end no matter what. But I kind of like 2, -3 because I have at least one positive. You know me, I avoid negatives if I can. Since I get to choose, I'm going to choose point B. Now, the other thing that we need to keep in mind is that when we're writing equations, x and y stay as x and y. And so that's part of why we have this little subscript of 1, so that you know that's not what's staying as a letter. That's where you're going to substitute in a number. So my point slope form is y minus y1 equal to my slope m times x minus x1. And so in those two spots, I'll drop in my point, my x1, y1 point that I chose from my graph. Now, notice x goes with x and y goes with y. So if you're writing it from left to right, it's backwards than your ordered pair, because your ordered pair is x, then y. But in your equation, it's y with y, x with x. So be very careful about that. You need to watch that. You also need to watch your signs. My x1 is a 2. That's what gets dropped into my green blob. Not positive. I don't change this sign. This is a negative. It's x minus x1. I don't get to change that unless I have to clean something up. So like when I go to drop my y coordinate, my -3, into my green blob, that I need to clean up, because subtracting a negative is the same as adding a positive. So y plus 3 and x minus 2, right? Okay, so then let's look for our slope. M is our slope, and so that's what we need to drop in front of our x parenthesis set. So back to our graph, we've got to make our slope ratio, and we know that's going to be change in y over change of x. And so you're thinking and counting on your grid your rise over run. So from point B to point A, from one nice neat point to the next, we had to go up 1, so increase by 1. And then we had to run to the left, so a negative direction, running to the left a negative 1, 2, 3, 4, 5 to get to point A. Okay, so my rise was a +1, and my run, since I went to the left, was a -1. And a positive divided by a negative is negative, and 1/5 cannot be simplified. So my slope is a negative 1/5. And that's the equation of your line. You've cleaned up everything that you can because you have your subtracting a negative that you turn to a positive. And so notice your point 2, -3. When you're seeing it in your equation, you see a -2 and you see a +3. So keep that in mind. This is point slope form. You can stop right here. We can graph from here because we know we have the point 2, -3 here at point B. From there, we would count our slope, up 1, left 1, or down 1, right 1, and to hit that line AB. All right, now let's take this point slope form and let's try converting that to standard form. So y plus 3 is equal to a negative 1/5 times x minus 2. We're in point slope form. If we want to convert to standard form, notice how standard form doesn't have any parentheses. Notice how standard form has x and y on the same side. I don't like anything like that right now. I have parentheses. I have y on the left side and x on the right side. It looks totally different. And so we're going to need to do some work to convert and rewrite in standard form. Now, if I have parentheses, that's because this negative 1/5 is shoved right up against it, and we know side by side means multiply. So we need to distribute to eliminate those parentheses. If we want to ditch the parentheses so we can head to standard form, we're going to have to multiply everything by a negative 1/5. And many of you are tapping out right now going, gross, I don't want to, I don't like fractions, I don't like them. I want to get rid of them. Okay, you have that option. That's completely fine, but let's talk about it. If you don't want to have your fraction, what is it that's creating that fraction? It's this dividing by 5 that's creating the fraction, right? If we weren't dividing by 5 and we just had that negative 1, we wouldn't have fraction, we wouldn't be freaking out right now. So how do we undo dividing by 5? We multiply. So if we're going to multiply by 5 on this side to ditch my fraction, then I'm going to have to multiply this entire side by 5 as well. Now, here's the nice thing on the right side. I'm really doing 5 times my negative 1/5, and in parentheses, I'll still have my x minus 2. But I can multiply here first, right? Multiplying from left to right before I have to distribute anything. Okay, so we're going to do this first, and then we'll finish and distribute. Okay, so let's go with that. We're working here on the right side. 5 times negative 1, right, straight across the top. Numerator times numerator. 5 times the negative 1 is a negative 5. And then my denominators, 1 times 5 is 5. And I still have my x minus 2. Now, what is a negative divided by a positive? Negative divided by a positive is negative. Anything divided by itself is 1. So negative 1 times x minus 2. Right, we can clean that up and get rid of that fraction so long as whatever we do to one side, we're doing to the other. So I also need to distribute this 5 times my y plus 3. So 5 times y would be 5y. 5 times 3 would be a positive 15. So let's update that. We now have 5y plus 15 is equal to negative 1 times x minus 2. Okay, so we need to distribute that negative 1 so we can get rid of our parentheses. No fractions now. I'm sure we're much happier. So distributing, we would have negative 1 times x is negative x. Negative 1 times negative 2 is a positive 2. So 5y plus 15 is equal to a negative x plus 2. Now, if I want to go to standard form, I need x and y on the same side. If I were going to slope-intercept form at this point, I could totally do that. I'd have to get y all by itself. So I'd have to subtract my 15, and then come back through and divide by 5, right? I could do that. That's no problem. If I wanted to go to slope-intercept form, then I wouldn't be ditching my fractions from the beginning, right? Because we'd just be undoing that again. But I want to go to standard form. That means I need to get x and y on the same side. And so right now, let's go up here so we have a little bit more room. Right now I have 5y plus 15. My y is on the left. My constant, I got a constant on the left, that doesn't belong there, is equal to negative x plus 2. This constant of 2 is fine on the right side, but my x should be on the left. So how am I going to undo that? I'm working to move things on either side of my equal sign, which means I'm doing my order of operations in reverse. I'm going to have to add x and add x. Meanwhile, I want to move my constant of 15 where it should be on the constant side on the right side. So to undo that addition, I will subtract 15, subtract 15. I'm okay with you making two moves at once as long as you show what you're doing to make your thinking visible. Okay, so this is going to be 0. I have a 5y and an x. I can't combine those, so they just stay as one long string. X plus 5y, since that's a positive 5 here, is equal to, this is 0, so that's out. Positive 2 and a negative 15 makes a negative 13. And so now I'm in standard form. Ax plus by is equal to c. We see our constant on the right side.